Bismillahirrahmanirrahim. Assalamualaikum and hi everyone. Okay, hari ni we're gonna continue with chapter 5, which is Statically Determinate Space Frame. Okay, so previous chapters kita dah belajar pasal statically determinate untuk truss dan juga statically indeterminate untuk truss. So in this chapter kita akan analyze the statically determinate space frame. Okay, so in this chapter we will focus on the space frame. Alright, okay, as usual kita akan ada learning outcome. Learning outcome which is at the end of this semester you guys should able to obtain or to gain this 4 point, which is you able to define the space frame, name the types of the support used in the space frame. The third is you are able to determine the stability and determinacy of the space frame, and lastly you able to calculate member forces of space frame by using the tension coefficient analysis. Alright, so let's start with the introduction. Apa itu space frame? Okay, space frame is a 3D dimensional structure that is usually constructed from the same fundamental triangle form associated with the plane frame. Okay, maksudnya kita akan ada satu plane frame. Maksudnya dia plane tu planar, maksudnya dia one apa mendata macam tu, planar frame. Okay, so the figure 5.1 okay, here shows that there are 3 members. Okay, 3 members, which is member 1, 4, 2, 4 and 3, 4 are added to the basic 3 member plane trusses. So ini adalah plane trusses kita. 1, 1, 2, 3. Okay, so plane trusses ni kita dah tengok dekat dalam previous chapter. Okay, so kita dah tahu dah plane truss dia adalah 1, 2, 3. Tapi dalam chapter ini dia jadi space frame bila wujudnya 3D structure. Okay, so dia ada triangular form associated with the plane frame. Maksudnya dia ada triangular yang wujud bersama dengan plane frame. So you guys can see this 1, 4, 2 is the triangular form. 2, 4, 2, 3, 4 is a triangular form. And also 1, 4, 3 is a triangular form. Okay. Okay, one to each of the existing joint and attach to the other end to a new out of the plane joint 4. Okay, kalau awak nampak ini adalah dia punya planar plane frame. Okay, so akan ada new joint here, which is out of the plane. Okay, so this is the simplest form of the space frame. Then the newly formed structure is a simple space frame known as tetrahedron. Okay, this is called as a tetrahedron, which is a very stable geometry. Okay, so figure 5.2 shows the typical application of the roof space truss for a large span structure, which is such as the sport complex or aircraft hangar. So ini adalah the application of the space truss. Okay, so here is the advantage of using the space frame. Okay, you guys can read here, but the point is, first of all, of course, the space frame is lightweight. Okay, So most of the advantage of the space frame is it's lightweight. Okay, and the second, such unit can be easily transported and rapidly assembled on site by semi-skilled labor. Consequently, space frame can be built at a lower cost. Okay, maksudnya dia mudah untuk dipindahkan, dicantumkan, disambungkan oleh dekat on-site, dan juga ini akan menyebabkan cost to build it is lower. Okay, so a space frame usually is sufficiently stiff. Okay. Okay, and lastly is the space frame possesses a versatility of shape. Okay, so dia boleh versatilekan dia punya shape and form, and can utilize a standard model to generate the various flat space, grid, and so on. Okay, so these four is the most or the several advantage of using the space frame. Okay, so there are kalau sebelum ni kita belajar in the previous lesson, we learned that types of support that we know, such as the pin, okay, such as the pin roller. So we already know about the pin, and also with the fix. Okay, so pin and roller. So these three is a common, we already know. Okay, but in this topic, I'm going to show you the types of the support which is not you guys not familiar yet. Okay, so this is the first one, which is we call as a short link. So for a short link, you're gonna have one reaction. Okay, so also same with the roller. You can see here, this is a short link, this is a roller, so also will give us the one reaction. Okay, so one reaction for roller and one reaction if the support is the short link. Okay, so you need to recognize what kind of support in this chapter. Okay, so the third one called as a slotted roller constrained in a cylinder. Okay, so slotted roller constrained in a cylinder, will give us a two reaction. Okay, so and lastly is the ball and socket joint. Okay, so ball and socket joint is will give us the three reaction. Okay, so you need to recognize these types of support. Since we have short link will give one reaction, roller will give one reaction, slotted roller will give us two reaction, whereby the ball and socket roller will give us three reaction. Okay, this is the example. Show the reactive force of the support if the space truss is supported by a ball and socket joint at A. Okay, so this is the ball and socket joint at A. So this will give us the three reaction. Okay, so this will give us the three reaction. Okay, so the second is a slotted roller at joint, slotted roller joint at B. So this will give us two reaction. Okay, whereby a cable will give us a one reaction. Okay, so a cable is same as a short link. Okay, so we're gonna show the reactive forces, the reaction of force at the support. So we have 3 at the joint A, whereby at joint B we have 2 reaction, and at joint C we will have a 1 reaction. Okay. Alright, so the determinacy and the stability. Since the space frame is in the 3 dimension, so sekarang dia dah bentuk 3D. Okay, so dia dah bentuk 3D. Okay, there will be a 3 equation of equilibrium for each joint. So sekarang ni dia 3D, so dia akan ada Fx, Fy and also Fz. Okay, so the external stability of the truss, of the space truss, require the support that the support reaction keep the truss in force and moment equilibrium. Okay, so generally the least number of required reaction for stable and externally determinate is 6. Okay, so sekarang dia punya yang stable adalah 6. Kalau kita punya truss yang sebelum ni kita dah belajar, truss dia punya R yang stable adalah 3. So in this case adalah 6. Okay, so sorry. Alright. Okay, so determinacy and stability. Thus, for the external stability and determinacy, R is equal 6 will give us the determinate truss, whereby less than 6 unstable. So R greater than 6 is externally indeterminate. Okay, for internal determinacy, we use this equation. So previously, our equation is, for the truss, M plus R is 2J, whereby equal or greater or less. Okay, so but for the space frame, we use this kind of equation. So they will become 3J. Okay. Okay, so this is the example. So determine the determinacy of the frame below, connection to the foundation, the ball and socket. Okay, so M here is member is 3, 1, 2, 3, and joint is 4, 1, 2, 3, 4. R is 9, whereby dia kata connection are ball and socket. So ball and socket will give us the 3 reaction. Okay, so here we'll give 3, 3 and 3. So M plus R is equal 3J. So will become the determinate. Okay, so similar with this case. Okay, so in this case, M is equal 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so M is equal 9. J is 1, 2, 3, 4, 5, 6, 6. R is 9, which is here support is socket, ball and socket joint. So this one also ball and socket joint. And also this one will give us the 3 reaction. Okay, so R here is 9. So we substitute in this equation, which is 3J. So we got same as the determinate, equal. Okay, right. So lastly, for this video, this is the assumption for design, which is the member are joined together by a smooth pin. Okay, the load and reaction are applied generally at the joint. Okay, the centroid of each member are straight and concurrent at joint. So I'm going to continue next in the next video. Alright, thank you. Assalamualaikum.